Hello, my dear students. Okay, I'll try a transition effect. Okay, so 1, 2, go. Did it take effect? Did my shirt become brown? No, still black, no? Let's try again. I think this time it became black. No, just kidding. Okay, there is no transition effect. This is just a blind gesture. So, hello, my dear students. My name is Benatang Paton, and I welcome you to the channel Classroom, where we learn together. So, there has been some delay. If I'm not mistaken, the last video which I uploaded was 4 days ago. So that was quite late. But here's my story, my part of the story. So in my defense, what I have to say is that I got sick. Okay, I was unwell. I got cold. I got down with fever, and so I'm recovering. So today I'm feeling much better. Okay, I did try recording yesterday and the day before yesterday, but then I was not feeling well. So it was like kind of a enforcing on myself. So it did not turn out very well also. So I decided to take complete rest, get healed myself first, then appear before you. So today I'm very much well. I'm 90% well. So I'm back to my old self. Okay, this is how I want to be. Okay, in my fullest potential, in my best form, so that I can deliver quality knowledge to you. Okay, so that I can utilize all my resources and impart knowledge, whatever okay I can give you. So I want to give my best to you all, my dear students. So I thank you all once again for tuning in and learning from me. So without further delay, okay, let's continue to our lesson. The topic for today is resistance. Okay, a very important and a very easy lesson. So without wasting time, let's jump into the lesson. So you know the drill, my dear students. Grab a notebook, grab a pen and a pencil, and take down the notes. Okay, because this will serve as a very important notes for your exam. Okay, so summer breaks are going on, so I hope you're all enjoying your summer break. Okay, I'm also enjoying my summer break, but I got sick, so some few days of my summer break gone. I still have around a week, so let me try to find some recreation for myself so that I will also enjoy my summer break. Okay, so resistance. What is resistance? Let's first define what resistance is. So what is resistance? Question mark. So resistance is opposition to the flow of charge. Okay, so that is what the resistance is. So we'll write resistance is opposition to the flow of charge. My dear students, this is the definition of resistance. Okay, resistance is simply opposition, opposing. Okay, somebody says black, you are saying no, I oppose it, it's not black. So opposition to the flow of charge. So let me elaborate on this a little bit. So let's take a wire, and then the charge particle is here. Okay, this charge will move from this end to this end. Okay, now so the charge will move from this end to this end, but what happens is that sometimes there are particles present in the wire, okay, which are called resistances. And what are those? These particles are atoms only. So we have atoms here. Okay, let me draw these black atoms. Okay, these are atoms. These can be protons, these can be neutrons. Okay, and now what are they going to do? They are going to cause opposition to the movement of the charged particle. So now how will this charged particle move? Now this charged particle will have to move from this end to this end. So he will still move, but now because of the presence of this opposition, now when this charged particle move, the charged particle will collide with them, and then what will happen? Collision, multiple collision will take place. So first of all, what happens is that because of the presence of these resistances, okay, which are particles or atoms, okay, what happens is that the electron, the charged electron, undergoes or experiences collision. Point number one, it experiences collision. This collision is what we call resistance. This is what resistance is. Simple. Okay, the collision which the charged particle experiences because of the presence of obstacles in its path is what we call resistance. This can also be one of the definition of resistances. So you can easily define resistance. Once you understand it, it's very easy to define. So resistance is opposition to the flow of charge. The charge particle is here, okay, and these particles, what are they going to do? They are going to oppose the flow of charge. So they are not going to let the charge particle move freely. So they are going to cause opposition. And how will the charge particle pass through them? When the charge particle tries to pass through the opposition, it will experience collision. Multiple times of collision. This collision is what we call resistance. Are we clear? Yes. Okay, so let's move to the next one. So this is the definition of resistance. Okay, then the formula. Okay, let's write some important points here. Formula of resistance. We have two formulas of resistances. R is equal to V by I. This is one formula. Okay, this formula is taken from Ohm's law. This is taken from Ohm's law. Remember Ohm's law? V is equal to IR. We need a formula for R. So R is on this side. Keep him there. Okay. V is on this side. V is not going to move. Let him be where he is. I, current, will come below I. So this is the formula which we wrote. Alright. So don't memorize. Just remember Ohm's law and derive the expression by yourself. Okay. Next, we have another formula. And this second formula is the actual formula of resistance. So R is equal to rho L by A. This is the most important formula of resistance. Okay, so there are two resistances. This is also formula of resistance. This is also formula of resistance. We will be deriving this very soon. Okay, in the later part of this same video only. So this is the formula of resistance. Then the unit of resistance. Anybody who can tell me the unit of resistance? What is the unit of resistance? Pause the video and write the answer. Yes, the unit of resistance is ohm. OHM, ohm. In the bracket you can write this symbol. This is called omega. Okay. Then the symbol of resistance. How do you draw symbol? How do you draw the symbol of resistance? The symbol of resistance is drawn like this. Straight line, zigzag, like this. Okay, this is the formula of resistance. Next, we'll define 1 ohm. Okay, these kind of questions are they do ask in exam. Define 1 ampere, define 1 ohm, 1 joule. This kind of 1. Okay, 1 diopter. So many questions about this 1 are there, and most of the students, you don't study this. Okay, because you find it a little difficult. But these are the most important questions again. So you should study this kind of questions. Okay, so let's define 1 ohm. So define ONE, 1 ohm, or we can write 1 ohm. So what is 1 ohm? Resistance is said to be 1 ohm when 1 volt of potential difference is applied, which allows 1 ampere current to flow through it. This is the definition of 1 ohm. So what is 1 ohm? Resistance is said to be 1 ohm when 1 volt of potential difference is applied, which allows 1 ampere of current to pass through it. Okay, so kindly remember this definition of 1 ohm. All right, so we will move to the next topic, which is a very important topic, factors which affect resistance. Okay, so let's erase this one. So if I ask you, what is resistance? What is resistance? Then what should your answer be? What should your answer be? Your answer should be, resistance is opposition to the flow of charge. Because of opposition, collision takes place, and this collision is what we call resistance. All right. So next topic, factors factors on which resistance of a conductor depends. Factors on which resistance of a conductor depends. Or sometimes this topic can be asked in another form. The topic can also be, explain the dependency of resistance. Dependency of resistance. Okay, this is also this heading and these two headings. Okay, they will have the same answer. Okay, dependency of resistance or factors on which resistance of a conductor depends. They will have the same answer. So there are 4 factors on which resistance of a conductor or a wire depends. Let's understand them one at a time. Okay, so the first point number 1 will be the length of the wire. Length of the wire. Let's discuss this first. So now let me throw this question upon you all. A long wire and a short wire. Before we go into the discussion, try to develop the answer for this. Which of them will have more resistance? The longer wire will have more resistance, or the shorter wire will have more resistance? Think on the answer, okay, while I draw a figure here. So let me draw a short wire, and let me also draw a long wire. Keep thinking about the answer, okay? I'll be asking you the answer. So let me draw the resistances here. So 1, 2, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, 1, 2. Have you thought of the answer, my dear student? Anyone who would like to tell me the answer? Which wire will have more resistance? A short wire will have more resistance, or a long wire will have more resistance? What have you come up with? So this is a short wire, and this is a long wire. What are these black dots? These black dots are the resistances. These are the resistances. These are the resistances. The charged particle is here. The charged particle is here. The charged particle will move from this end to this end. Will move from this end to this end. Now, what is the answer? A longer wire will have more resistance, or a shorter wire will have more resistance. It's very much visible from the diagram also, isn't it? That it is the long wire. Okay, how? But how? How is the long wire having more resistance? See, I have drawn the resistances here. The wire is long, so it will have more resistance. Okay, the wire is short, so it has got less resistance in it, is it not? So here, what happens? How many resistances are there altogether? There are only six only. So the charge will try to move from this end to this end. So in the process of moving, it will collide, no doubt. But how many collisions? Just an assumption. Okay, how many collisions did it take? 1, 2, 3. So here, 3 collisions. We can estimate that it took just 3 collisions for the electron to reach to this end. Okay, this is just an assumption, just to let you understand. Now let's go here to the long wire. so many oppositions here, so many. So you know what's gonna happen, more collisions will take place. So the more the collision, since collisions are resistances only, so more collision, more, okay, more resistance. Okay, so simple, more collision here. Okay, so more collision, so more resistance, so more resistance. Okay, so remember, my dear students, the longer wire has more resistance, the shorter the wire, the less the resistance, the longer the wire, the more the resistance. Okay, it's very easy, it's very well understood from this figure. I hope we are clear with this one. Okay, so we can write one mathematical expression here. So remember, we can just write down longer wire will have, you can write down this point, more resistance. Reason is because the oppositions are more. Okay, the resistances present in them are more, the opposition, okay, the particles which block the charge are more here. And then shorter wire will have less resistance. Okay, and then we can write one expression, resistance is directly proportional to length. Okay, Length. You can also write R directly proportional to L. Very important. Okay, remember this, resistance is directly proportional to length. Okay, remember, because if the wire is longer, resistance is also more. If the wire is short, so what the meaning of this one is that if the length is longer, arrow up means more, then the resistance also is more. If the length of the wire is short, then the resistance is also short. Arrow down means less. Okay, arrow up means more. Length more, resistance more. Length less, resistance less. Okay, so the relationship is that of direct. Remember, resistance is directly proportional to length. Okay, next point number 2. We'll go to point number 2. The next one is cross-sectional area. So the first point is resistance of a conductor depends on the length of the wire. We have already discussed that. The second point is depends on the cross section of the wire. So point number 2, cross sectional area. What is the meaning of cross sectional area? Anybody who would like to tell me what is the meaning of cross sectional area? I don't know, so you have to tell me. I don't know what is the meaning of cross sectional area. Seriously, I don't know, so you have to tell me. So please tell me what is the meaning of cross sectional area. It's a very fancy word and I did not pay attention to my teacher when he was explaining in the class, so I don't know. So now who will help me? Somebody please help me. I'm serious, somebody please help me. Alright, okay, I'm just kidding. Cross sectional area simply means thickness. Thickness, okay? So we are all aware of thickness, isn't it? We have thin and we have thick. So let's take two wires. One is a thick wire and the other is a thin wire. So this is a thick wire and this is a thin wire. And let us discuss the story of resistances in both the wires. I'll again ask you the question, which wire will have more resistance? Thick wire will have more resistance or thin wire will have more resistance? And I know your answer. And I know what is your answer. Should I tell you your answer? You are picking this. You are more inclined to pick this. So most of you have picked this. Or am I wrong? Okay, from my experience, okay, as a teacher teaching students all these years, many students have picked this, so I will go with this answer. Okay, if I am wrong, forgive me. Okay, so most of the students will go for this one. They will say, sir, the thick wire will have more resistance. Okay, now they are not wrong, okay, but once we discuss, it will be very clear to you. Right now, okay, discussion has not started, so it's okay. It's okay whether you pick thick or thin, it's okay, but let's discuss, and in the course of discussion you will understand which will have more resistance. Okay, so between a thick wire and thin wire, which will have more resistance? So the charge particle is the charge particle is here. Let's say charge particle is here, so charge will move from one end to the other end. Okay, now let's start with the thin wire first. So let us draw the resistances here. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I'll not draw more than this, okay, because you already know. Okay, I can draw a lot, but no need to waste time and draw that. And then how many did I draw? 4 now. So here also I'll just draw 4 only. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now let's start with the thin wire. Now this charge particle will move from this to this part, from one end of the wire to the other end of the wire. Now look at the spaces between the resistances. The spaces are too thin, not thin, sorry, too small. Okay, the spaces are too small. So having very small gap, what will happen? This charge will experience multiple collision. So when it tries to pass through, it will collide with this, then collide with this, and collide with this, and it will go on. Okay, if only I draw more resistances, it will experience multiple collision. So here, multiple collision. Now let's go to the thick wire. Now look at the spaces between the resistances. Wide, big spaces are available. So here, what will happen? The electron, okay, the electron can easily avoid these resistances. Okay, it will try to avoid some resistances. Of course, why will he knowingly go when he sees electron? Now, why will I go? Okay, when I know that the bully is there. Let's say there's a bully and I see him there. Okay, now I have options to go here or here. Since there are 3 options available and I see the bully in one corner, so why will I go here? I will go here, isn't it? Where I don't see any bully. So just like that, even the charge particle is smart enough. So what he will do, he will not go, okay, when there are spaces available to squeeze. So the charge particle will not go, okay, and collide with them. It will try its best to avoid. See, charge hates collision. If you are a charge, you will hate collision. I am a charge, I hate collision. So I don't want to collide. I want to move freely. I don't want to be disturbed by anybody. Just let me move freely. I am a charge. Okay, let me move freely. Do not disturb me. That is what charge wants to do. But because of the presence of resistances, charge experiences collision, and the collision brings about resistance. Okay, so because of these obstacles, okay, resistance is brought about. So here he is getting his dreams are coming true. So he sees that there are wide gaps between the obstacles. So will he go and collide with the obstacles intentionally? No, he will not. So what will happen? Okay, he will try to avoid them as much as possible. So here, of course, he will experience some collision, but the number of collision will be much less because of the wide gap between the opposition particles. Understood? Okay, so here the collision will be less. So less collision here. So the bigger the wire, the more the gaps between the opposing particles, thereby charge can escape freely. The thinner the wire, all the opposing particles are tightly packed there in that small area, and so charge, okay, experiences multiple collision when trying to pass through a thin wire. So now you have the answer with you. Which wire will offer, okay, more resistance? The answer is thin. It's thin wire. Okay, thin. So thin wire. Okay, thin wire will have high resistance, and thick wire will have less or low. So here what we understand is that if the thickness is more, so arrow up means more, thickness more, resistance less, arrow down less. If the thickness is less, because it is thin, is it not? So the thickness is less. So the thickness is less, resistance is extremely high. Yes or no? So this is the exact opposite of this one. Here wire, length of the wire more means resistance also more. If the length of the wire is low, then resistance is also low. Such type of relationship is called direct relationship. Here opposite is happening. This is called inverse relationship. Here thickness increasing, thickness is increasing, resistance on the other hand is decreasing. Here thickness decreasing, resistance is increasing. So this is called inverse relationship. So the relationship between cross-sectional area and resistance is that of inverse relationship. Okay, so what we will write like this: resistance is inversely proportional, means 1 by A. This is the formula, this is the expression that you have to write. So we have written two expressions, one here, second here. All right, now let's move to the third point. The third point, point number 3. So point number 3, if you understand these discussions, then you will easily master resistance. Okay, it's very easy, this topic is easy. So point number 3 is temperature. Temperature. So what is the story about temperature? So temperature, so let me throw the question to you. So we are talking about temperature. So with the increase in temperature, will it have more resistance or will it have less resistance? That is the question which I am asking you. So you tell me, if the temperature of the wire increases, will the resistance increase or decrease? Think about the answer and tell me while I'll draw a figure here. So we have we are talking about temperature. So let's take a wire and then let's hit the wire. So this is my fire burning. There's a song, fire burning. No, I think I'm singing it wrong. Okay, but I feel like there's a song sung by Sean Kingston, I think. Somebody call 911. Yes, is it not? Yes, it's there. Okay. So it's a good song. Okay, I don't know whether you have heard or not, but you can go and check. Okay, Sean Kingston and was it Justin Bieber? We go and check. Okay, so this is the fire. So now this is a conductor, this is the wire, this is the wire, this is the wire, and then now see, when we hit the, so let's draw the atoms. So the atoms are here, so let's draw the particles here. The charged particle is here, and then the atoms are here. Let's draw the particles here. There are some gaps between the particles now. Okay, so everywhere there will be, I'm not drawing everywhere, but it will be everywhere. Okay, it is. Okay, so there are some visible gaps. Okay, there are some visible gaps between the obstacles. Okay, between the obstacles. Now because of the presence of this, the charge will experience collision. Okay, but we are heating it again. So we're heating it again. So on heating, what will happen? The temperature of the wire will increase. The temperature will increase. Arrow up means increase. Yes or no? Will the temperature of the wire increase? Yes. How is the temperature of the wire increasing? Tell me the reason. How is the temperature of the wire increasing? What are we doing to the wire? Yes, we are heating the wire. Come on, we are heating the wire, isn't it? We are heating the wire. So the wire is receiving heat energy. So using the heat energy, the temperature of the wire is increasing. Okay, when the temperature of the wire increases, now the heat energy is absorbed by these particles. The heat energy is absorbed by the atoms present in the wire. So what happened? The kinetic energy of the atoms will increase. Kinetic energy means, okay, energy associated with moving object. So this stationary objects, these stationary atoms, these are actually stationary. These are actually stationary. They are not moving actually. They don't move. But now, because of giving tremendous amount of heat energy, those stationary objects which are like this now will start vibrating up and down or left and right like this. So they will move up and they will move left and right like this. At the same time, they will also move up and down like this. So we have this kind of movement. Okay, this is a little difficult. Okay, difficult type of movement. But the atoms will do this kind of movement: up, down, left, right, up, down, left, right. Okay. Wow, this is a good exercise, na? Up, down, left, right. So this type of movement, these atoms will start executing this type of movement. Why are they doing this type of movement? Because they receive heat energy. So the motion will increase. So their motion increases. Remember, previously, when this heat was not given to them, they were stationary. But now, because of the receiving of heat energy, they will move up, they will move down, they will move sideways, left ways, right ways, like that. Okay, now, then what will happen? Then what will happen? All of them will start moving. They will start moving. So they will be moving. Okay, they will be moving. Continuous movement will be there. Now you tell me, what will happen to this poor charge? Will it be easier for him to move now? No. Now, what will happen? Now he is a charged particle, so he will move from this end to this end. But what will happen to him? His movement, okay, his movement has become very, very, very hard now. Now, as he tries to move, okay, the atoms are also moving. The atoms, the opposition are also moving. And so the gap has become extremely small again. So now, as he moves, he will experience multiple collision. Tremendous amount of collision he will experience. So he will experience multiple collision, thereby resistance is more. So on a hot wire, on a wire whose temperature has increased, the resistance is more. So for all this reason, what will happen? Resistance will be more. Resistance also high now. Temperature increases, kinetic energy of the particles increases, the motion of the particle increases, resistance also increases. So temperature, what is the story of temperature? With increase in temperature, when the temperature increases, resistance also increases. INCREASES, increases. All right, so simple. Temperature increases, resistance increases. Arrow should be up. Temperature increases, resistance increases. Clear? And if temperature goes down, resistance will also go down. Clear? Now we have the fourth point, and the fourth point is a very important point, so I'll erase this one and we will discuss in detail, because the fourth point is one of the most important point and also one of the most confusing point for students as per my experience. The fourth point is called nature of the material. Nature of the material. So the fourth point is called nature of the material. Very simple, isn't it? Nature of the material. We all know what is material. Okay, good material, bad material, we know. So nature of the material. Nature means what? Type. Type to na. If you're selecting a good material means you know how to select the good type. If you're selecting the bad material means you don't know which is the good also. So type of material. There are always types, isn't it? Good type, bad type, good person, bad person. Types are there, okay? Positive, negative. Okay, even charge has got two types though. So type of material or nature of material. Okay, this is also known as resistivity. From this part, students get confused. Till this much is easy. As long as it was nature of the material, you were smiling and you were like, oh, easy, good, I can understand. Okay, sir, what was sir saying that this is confusing? No, it's not confusing. It was easy. Now these terms, okay, the moment I say resistivity, now students start getting confused. Okay, you don't need to get confused. Don't get confused with these fancy terms, okay? These are just fancy terms which you just have to get used to it, okay? Just get used to it. Since these are words we don't use again and again, you tend to overreact with it. Don't overreact with these things, okay? Just treat them like normal, okay? You don't need to give them special attention. Just treat them like normal. So resistivity, nature of the material, in other words, resistivity, okay? Or specific resistance. So the reason why students find this difficult is because we are using so many fancy names. So I don't blame you, okay? If I don't tell you, if I did not write this thing and just told you resistivity and specific resistance, you will have, okay, close the chapter. You will say, no, too hard. But no, specific resistance, you don't know, no problem. Resistivity, you don't know, no problem. But at least you understand, nature of the material, you know, nature of the material. Simple English, okay? So learn from here then, okay? So what is this? So now they are same, okay? They are same. But there is a definition for specific resistance or resistivity. So let's first define what is resistivity. Resistivity. And you have to study this definition. In exam, they will not ask you define nature of the material. They will not ask you. Okay. They will ask you define resistivity or what is specific resistance. Same only. Resistivity or specific resistance, they are same. The definition is same. Okay, they have both the same definition. So let us first define this. So resistivity is the property of a material to oppose, underline, the flow of current. That's it. Please read the definition once, my dear students. Resistivity or specific resistance. What is it? Resistivity or specific resistance is simply the property of a material to oppose the flow of current. It's a simple definition. It is the property present in the material by default when it was created. Remember, it was not put there by human beings. By default, it was there from the beginning. Okay, so it is a property of a material, okay, to oppose the flow of current. Okay, so the property which the material possesses within itself, okay, to oppose the flow of current. This is called resistivity. So we are surrounded by many materials. Okay, we are surrounded by many materials. This is a whiteboard. This is a material. The borders are aluminum. That is a material. I am holding a plastic marker material. The tip of the marker is cotton material. The cloth I am wearing is cotton material. So we are surrounded by many materials, and these materials, they themselves, they have in them this property. Okay, some of them they oppose charge, some of them they don't oppose charge that much, some of them they don't oppose charge at all. So we have substances which completely oppose charge. We have substances which allow partial movement of charge, and we have substances which allow free movement of charge. Are you getting my point? What resistivity or specific resistance is? It is the property of the material to oppose the flow of charge. So some of them, remember, okay, some of them have tremendous opposition. They are called as insulators. Some of them have moderate resistance or resistivity. That means they are called as resistors. Okay, resistors are those substances which allow partial movement of charges, and some of them have zero resistivity. That means they allow free movement of charge. That means they don't have any resistances in them. For example, copper, aluminum, silver, gold. Okay, so this is what resistivity is. Okay, so this is it. Resistivity is the property of a material to oppose the flow of current. For example, okay, remember, put one more sentence. Different, what we just discussed, we're writing materials have different resistivity. resistivity. Example, copper and glass. You want to make a wire. Your goal is to make a wire. Which one would you pick? Copper or wire? Glass? Yes, you will pick copper. You will not pick glass. You know, tell me, why didn't you pick glass? Why didn't you pick glass? You did not pick glass because glass opposes the flow of current, is it not? Glass does not allow charge to move over it or through it. So that means glass has got high specific resistance. That means glass has got high resistivity. The resistivity of glass is more. The property to oppose charge is more in glass. So glass is a bad choice to make a wire. So material, see how important material is. Okay, it is very important. The material is very important. This point is very important. Actually, this is a very important point. Nature of the material, don't take it lightly. Okay, if you make a mistake and take glass and decide to make wire, your experiment will fail. So you have to know. Okay, and everything is already studied, recorded, and printed out. Okay, if you study the books, if you study the textbook, if you study the materials, you will know. Okay, we have almost found, the scientists have already studied and written the specific resistance of all the substances available on Earth. So all you have to do is study only. Okay, so every specific resistance of the material have been found and discovered, recorded also. So remember, to make a wire, we should use copper. Why is copper a suitable candidate for making a wire? Because the specific resistance of copper is low, the resistivity of copper is low, and in a wire we want charge to move. So selecting copper is the right material. Okay, so selection of the material is very important depending on your goal, what you want to do. Here you want to make wire, so copper should be selected because copper has got low resistivity. The specific resistance of copper is low. All right, see, it is this easy. Okay, it is this easy. So that is it. This is resistivity. Okay, so here let me give you the resistivity values of some materials. So we were discussing about conductors, insulators, and resistors, is not? So let me erase this one and quickly write that. We are almost at the end of the topic for today. So just to give you an idea, okay, so we have conductors, their specific resistance is, conductors have nil resistivity, 10 to the power minus 9, 10 to the power minus 10, okay, ohm meter. Oh yes, I am supposed to tell you, yes, before we go here, remember, okay, here, write down some more points before we go here. So resistivity, okay, some more points you have to write here. So the unit of resistivity is ohm meter. Okay, this is OHM, ohm meter. All right, the unit of resistance is ohm meter, and then it's denoted by this symbol. This is called rho. There is space here, so let me just write here rho. This is called rho. All right, then we'll take the two equations which we have discussed earlier. So R directly proportional to L, remember this equation. The second one, R inversely proportional to 1 by, which is the area of cross section. So comparing these two equations, equation 1 and equation 2, what you will get? You will get R, okay, directly proportional to L but inversely proportional to area of cross section. Okay, now we will remove this. We'll remove the sign of proportionality, and to remove the sign of proportionality, we will bring the sign of equality. Now, since we have removed the sign of proportionality and bringing the sign of equality, we have to bring a constant. That is the general law. Every time we remove the sign of proportionality and write the sign of equality, we have to always bring a constant. So the constant that we'll be bringing is this rho L by A, and this is it, my dear students. This is the formula. This is the actual formula of resistivity or resistance. Sorry, not resistivity, I take back. This is the actual formula of resistance, because this is R, resistance to na. So this is resistance and this is resistivity. This is resistivity. What is resistivity? Tell me, what is resistivity? See, suddenly I'm asking you this question. So are you able to answer the question? What is resistivity? What is resistivity? Do you have the answer with you? You should have the answer with you. What is resistivity? Resistivity is the property of the material to oppose the flow of current, okay, or charge. So this is length and this is, what is A? What is A for? A is area of cross section. Area of cross section. So this is the formula of resistance. This is the most important and the official formula of resistance, okay. So now we can go here. So conductors have nil resistivity, remember this, okay. So this is the unit, okay. I was reminded by this without telling you about ohm meter. If I start writing ohm meter, it will only confuse you. So I totally forgot about this thing, okay. So the unit of resistivity is ohm meter, okay. Remember this one. This is ohm and this is meter, ohm meter. Next, conductors, then we have resistors. Resistors are those substances which allow a little bit of charge to pass through them. Resistors have medium or moderate, let's say medium resistivity. So their values will be around 10 to the power 1 and 10 to the power 2 ohm meter, okay. And finally, insulators. Insulators have high resistivity. Their resistivity values are like 10 to the power 14, 10 to the power 16 ohm meter. So these are the values of resistivity. Check out the resistivity values of insulators, okay. Insulators, they have got tremendously high values of resistivity. 10 to the power 14. You know how much is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This much resistances they carry. That's quite a lot, isn't it? Okay. So this is what you have to remember. These are very important, okay? These are very important. With this, see, you know what conductors are. Substances like copper, aluminum, silver, gold. These are all conductors. These are very good conductors. Okay, these are very good conductors. They allow charge to move freely. How are they able to move? How are they able to allow charge to move freely? It is because they do not oppose the flow of charge. That means they have nil resistivity. Having nil resistivity, you have to remember the values also. So Sri is saying nil resistivity. So what will be their values? So their values are in minus only. 10 to the power minus 9, 10 to the power minus 10. 10 to the power minus 9 means 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9 like this. Okay. If you divide this, you will get 0.00000, it will go like that. Okay. So very, very less resistance. That's why they are called nil. Nil means almost like not having, isn't it? Nil, isn't it? So conductors have nil, means it's like almost they don't have. Okay. Then we have resistors. Resistors are those substances which allow a little bit of current to pass through them. We'll be discussing about some resistors very soon, like tungsten. Okay. So they do allow a little bit of charge to pass through them. Their values are 10 to the power 1, 10 to the power 2. 10 to the power 1 means 10 only, 10 to the power 2 means 100. Okay. And insulators, substances like glass, substances like paper, substances like wood, they have tremendously high resistivity. Their resistance values are this much, see, this much, 10 to the power 14, 16, tremendously high. Okay, and because of this, they do not allow charge to even penetrate. Charge cannot even penetrate. Okay, charge cannot move, charge cannot go in, charge is stuck here. Okay, so charge will not be able to move from this. Charge will not be able to move from this end to this end. Charge is blocked. There's a wall blocking charge, so charge cannot move. So this is the story of resistivity for conductors, resistors, and insulators. So if you remember this, if you know these things, okay, it becomes very easy for you to identify whether a given substance, suppose for example in exam, your teacher gives you 1.6 into 10 to the power minus 19 ohm meter in MCQ, and then the teacher is asking you identify this substance. Is it a conductor, insulator, or resistor? Now it will be very easy for you to understand, or for you to answer this question. Before though, you may be thinking like, I hate this kind of questions, okay? But now though, you will appreciate this kind of question because now it's very easy. Now you know, okay? So please identify this. Please identify this. Is this a conductor, a resistor, or insulator? The answer is a conductor. This is a conductor. This is a conductor. How do I know it's a conductor? Look at this. Look at this. It's in minus, is it not? So it's in minus. So this is a conductor. Alright. So this is how they may ask you questions. But you should be ready to answer these questions, okay? So this is it, my dear students. We have come to the end of the topic. Now, before I leave you, I have a question. So the question is, the question for today, and I want you all to participate and answer, give me the answer in the comment box. I want participation from you because that is the way, okay, you encourage me, and that this is also the mode by which I know that you are participating and you are learning. So please participate. So this is a request, okay? This is a request. I'm not threatening you, okay? I don't threaten anybody. This is a humble appeal and a request, okay, to participate. So what is the unit of resistivity? Simple, okay? Simple question. You kindly give me the answer in the comment box. Decorate the comment box with your answers, which I will read and give a like and give you a comment again. So thank you all, my dear students, for tuning in and watching. I pray that you have understood something, okay? If you have understood something, that makes me happy, and that's my goal, that is my motive behind these sessions, okay? So thank you all, and I'll see you again in the next video.